Before moving forward to Poisson regression model, first talk about count data. So count based data contains events that occur at a certain rate. The rate of occurrence may change over time or from one observation to next. Example, number of vehicles crossing an intersection per hour. Data of count should be of non-negative integers. Regression techniques such as OLSR may not appropriate for modeling such as OLSR works based on real numbers. Poisson regression model is popular technique for developing regression models for counts. A Poisson regression model for constant lambda. If the event rate lambda is constant, we can simply use as modified mean model for providing future counts of events. A Poisson regression model for non-constant lambda. Now we got to see the fun part. Let us examine a more common situation where one lambda can change from one observation to the next. In this case, we assume that value of lambda is influenced by a vector of explanatory variables, also known as predictors. We call this matrix of regression variable x. The job of regression model is to fit the observed counts y to the matrix of regression variable x.
Poisson regression is a statistical technique used for modeling count data, which means that it is most suitable for dataset where the outcome variable is a count variable. So we will be making use of the dataset which contains the details of the bicycles travel through number of bridges in the New York City. The dataset contains various columns such as the number of bridges. So the counts were measured daily from the April of 2017 to October of 2017.
Hello guys. Now for the code part, we will start by importing two libraries. After that, we will initialize some variables. Then we will use a for loop to generate random numbers using the random module. For each random number that is generated, we will then calculate the intertime arrival using the inverse of the CDF of exponential distribution. The arrival time is then calculated by adding the inter-arrival time to the previous arrival time. We will also keep a track of the number of arrivals per unit time interval. If the arrival time exceeds the current time arrival, the number of arrivals in that interval is stored in a list, and the number of arrivals counter is then reset to 0. And finally, we will print out the number of arrivals in each unit time interval as well as the mean arrival rate for the sample. That's it for the code side.
Some of the applications of Poisson regression are as follows. The first one is insurance claims. Poisson regression is often used in insurance to model the number of frequency of claims made by the policyholders. Insurance companies can make use of this technique to predict the number of claims that will be made in a number of days in a given period of time based on the various factors such as age, gender, driving record and many other relevant factors. So the second application is website traffic. Poisson regression is often used in website analytics to model the frequency of website visits. The technique can help website owners identify patterns in their website traffic and understand which factors contribute to visitor behavior.